From 380,000 years until about 200 million years into the universe's history is a time period known as the Cosmic Dark Ages. However, from 380,000 years until 5 million years into the universe's history, it wasn't really dark. There were a lot of photons of visible wavelengths, so that if we were there, we would actually see the whole universe being a uniform color. Nonetheless, because the Cosmic Dark Ages do officially start at 380,000 years, let's look back to that time. At that point, the electrons have combined with the nuclei to make stable, neutral atoms, and the photons have been released from the cosmic fog and are now traversing the cosmos freely, finally landing by us as the cosmic microwave background. The universe continues to expand, continues to thin out, being 3,000 degrees about 400,000 years into the universe's history, and only getting cooler ever since. But something fundamental changes at this point. You see, since 57,000 years into the universe's history, there was more matter than radiation. And ever since that point, at least theoretically, you should be able to have gravitational collapses. And for dark matter, that indeed has been the case since that time period. For ordinary matter, the story is a little more complicated. Ordinary matter has wanted to collapse this whole time and has been driven gravitationally to collapse, but the pressure from the radiation prevented it from collapsing. Until this time, matter had been bouncing in and out of the dark matter halos that it found itself around. But starting at 380,000 years, with the pressure from the radiation lifted by the freeing of the photons, the matter can now collapse in a sustained manner towards the center of these dark matter halos, and it promptly begins doing so. These regions of higher mass density originated from those quantum fluctuations during inflation and have been exacerbated by the superhorizon growth of density ever since, and the subhorizon gravitational collapse of dark matter from 57,000 years up until now, and now matter joins in. So over the ensuing millions of years, as these regions of matter continue to collapse and collapse towards the center of these halos of dark matter, the photons in the universe continued to lengthen as the temperature decreased and decreased and decreased. And by 5 million years, the majority of the photons had reached the infrared, and at this point, we would no longer be able to see anything because the photons are in infrared, and the universe would appear dark. And in this darkness, the matter is continuing to stir. Now, despite the fact that a gravitational collapse is now happening for dark matter and ordinary matter, inflation is still happening even in those very regions. So you have one region which is denser and one region which is less dense. Both of these regions, still at this point, are going through inflation. The more dense region is going through inflation slower because it's pulling back on inflation more, but nonetheless, the overall density of even the more dense regions is continuing to thin out and dilute as those regions continue to become bigger despite the gravitational collapse within them. This goes on for tens of millions of years. However, as the universe traverses the temperature of about 60 Kelvin, around 100 million years in the pitch black universe, that expansion halts for the densest regions. And those densest regions are now so dense that expansion has completely ceased, and the collapse can really be exacerbated and become more dense and more dense without the expansion of the universe diluting it. And in the darkness, the matter continued to collapse towards the center of the dark matter halo, these densest regions in the universe, and eventually enough hydrogen and helium gas congregated and brought about so much gravitational pressure that one proton fused with another, and voila, the first star in the universe is born. Those stars are fairly strange, but they're not our concern, because with the first star ends the Cosmic Dark Ages. So we'll take a look at that next time. Be sure to like the video and to subscribe if this is the kind of content that does it for you.